Astronomers have just confirmed something truly incredible. A galaxy that has stayed almost completely unchanged for more than 7 billion years. It's called Kids J0842+0059, and scientists are calling it a fossil galaxy. A rare remnant from the early universe that somehow avoided all the violent collisions and cosmic interactions that usually reshape galaxies over time. This galaxy was first discovered back in 2018 during the Kilodegree survey. A massive project that studies dark matter and large-scale structures in the universe. Kids J0842+0059 sits about 3 billion light-years away from us. At first glance, it looked like a normal compact elliptical galaxy. But when astronomers looked closer, they found something strange. Despite its huge mass, about 100 billion times the mass of our Sun, the galaxy was surprisingly small, old, and not forming new stars. Even more interesting, there were no signs of past collisions or mergers. All of that pointed to one thing: this could be a true fossil galaxy. A system that formed early in the universe and then simply stopped changing. To confirm it, scientists used the Large Binocular Telescope. Its powerful adaptive optics gave them images nearly 10 times sharper than the ones from the original survey. This allowed them to study the galaxy's structure and the ages of its stars with incredible precision. And the results were clear: Kids J0842+0059 is both compact and inactive, matching the models of a galaxy that formed quickly in the early cosmos and then stayed frozen in time. To give it some context, astronomers compared it to NGC 1277. Another relic galaxy that's only 240 million light-years away. It's also small and ancient, but it lives in a much more developed part of space and is far closer to us in time. That makes Kids J0842+0059 the most distant fossil galaxy ever confirmed. A rare window into how galaxies might have looked just after they first formed. This finding also shows that not all galaxies follow the same evolutionary path. Some, like fossil galaxies, formed fast, burned through their gas, and then stayed perfectly preserved for billions of years. So, why is this so important? Because Kids J0842+0059 challenges what we thought we knew about galaxy formation. The leading idea, called hierarchical assembly, says most galaxies grow by merging with others over time. We see proof of that everywhere, in warped spiral arms, tidal streams, and galaxies with stars of mixed ages. But a fossil galaxy doesn't fit that picture. Its compact shape, ancient stars, and lack of merger scars show that it formed extremely fast. Probably within the first 1 to 2 billion years after the Big Bang. And then just stayed untouched. That makes it a perfect time capsule of the early universe. Because it never went through later chaos. It shows us what galaxies looked like before billions of years of change blurred the picture. When scientists studied its chemical composition, they found signs that the galaxy went through an intense, brief period of star formation. And then suddenly stopped. One theory is that a supermassive black hole at its center heated or blew away the surrounding gas, cutting off star birth entirely. With no cold gas left, the galaxy simply went quiet. This makes fossil galaxies a dream for astronomers. They're clean, simple systems with a single generation of stars. Unlike most galaxies that have complicated, layered histories. That makes them perfect for testing theories about how stars and galaxies evolve. And because they've barely changed, they also help us study dark matter in its most original form. In typical galaxies, mergers mess up dark matter distribution. But in a fossil galaxy, it's likely still in its pure, untouched state, giving scientists a clearer look at how dark matter behaves. The discovery of Kids J0842+0059 has kicked off a new wave of research focused on these galactic relics. The problem is, they're extremely rare. Most galaxies have collided, merged, or changed countless times since the early universe. Finding one that hasn't is like finding a perfectly preserved fossil in space. That's where the next generation of telescopes comes in. The Euclid Space Telescope, launched by the European Space Agency, is designed to map dark matter and cosmic structure. But it's also perfect for spotting compact, quiet galaxies like these. Combined with powerful observatories like the extremely large telescope, scientists hope to build a full catalog of fossil galaxies, spread across different points in cosmic history. With that data, they can finally answer big questions. How common are fossil galaxies? Where do they form? And what makes some galaxies evolve, while others stay frozen in time? These answers could even explain why the cores of massive galaxies today are so dense. Maybe those cores started out as ancient fossils, just like Kids J0842+0059. And because fossil galaxies are simple, they act like reference points, helping astronomers untangle the complex history of galaxies that have lived more active, chaotic lives. In the end, the confirmation of Kids J0842+0059 gives us a direct window into the ancient universe. Unlike most galaxies, it has remained unchanged for billions of years. A true relic from the dawn of time. And as we find more of these cosmic fossils, they'll help us piece together the story of how massive galaxies first formed, and bring us closer to understanding how our universe truly began.